Welcome friends to my YouTube channel. Now on my last lecture I have told about the Laplace's equation of potential, and I also did few worked out problems related to gravitational potential, and there I took the example of thin spherical shell and later a solid sphere. Okay, now in our today's lecture I shall going to discuss an important topic that is called equipotential surface. Equipotential surface. Okay, so you can easily understand by seeing the name equipotential. That means the locus of all points having the same potential. Okay, a surface over which the potential at every point remains same. Okay, so a surface over which potential at every point remains same is called equipotential surface. Is called equipotential surface. Okay, so it is a surface over which potential at every point remains same. Okay, we can easily understand it. Now there are few important properties of equipotential surface that we have to understand. Okay, so the first property is that the work done in taking a charge from one point to another point in an equipotential surface is always zero. One thing must remember, these things we are also going to learn in electricity, and but here in gravitation chapter I just give a brief introduction of equipotential surface. We will also learn it in electricity chapter. Okay, Gauss's theorem in electrostatics chapter. So the first property is that work done in taking a charge from one point to another point. Okay, work done in taking a charge from one point to another point in an equipotential surface. In an equipotential surface is always zero. Okay, work done in taking a charge from a point to another point in an equipotential surface is always zero. So how we can verify it? So let's check how this can be verified. Okay, so how we can prove it? So let us take, this is an equipotential surface. Fine, so this is a point and this is point. This is say A point and this is B point. So what will be the work done in taking a charge from A to B? We all know. Okay, so this is a equipotential surface and there are 2 points A and B. Now what will be the amount of work done in taking a charge Q in moving from A point to B point? We all know that VA minus VB, the formula is WAB by Q, because we all know that work done, this is nothing but charge multiplied by potential. So now from the definition of equipotential surface, we all know that VA equals to VB. Okay, so WAB by Q, this is simply 0, So what will be my WAV? My WAV will be 0. Okay. So this is the first property of equipotential surface, that work done in taking a charge from one point to another point in an equipotential surface is always 0. The formula is this. So from the definition of equipotential surface, here VA equal to VB. So WAV by Q is 0. That means WAV is 0. So this is the first property. Okay. Now what is the second property of equipotential surface? Okay. Now the second property is that electric field is always perpendicular to the equipotential surface. Okay, electric field is always perpendicular to the equipotential surface. So how we can verify it? So just draw a equipotential surface there. Okay, we just draw a equipotential surface. Say this is A point and this is B point, and we already seen that work done in taking a charge from A point, say from this to this, is always 0. That we previously proved. And now here we consider a charge, but we take a unit charge. Okay, we take an unit charge. So if we consider a unit charge, so what will be the electrostatic force? Q into E. So here we consider unit charge, that means F is equal to E. Okay, we consider a unit charge. Okay, so what will be the formula of work done? Work done, this is simply F dot dr. Okay, and what is F? We find F is equals to E dot dr. Okay, so if we this is E dr cos theta. And again, from my previous section, we have found that work done is 0. So this is 0. E cannot be 0, displacement cannot be 0. So what is 0? Theta is 0. That means theta is cos theta is 0, theta is pi by 2. So the angle between E and dr is perpendicular. Okay, so electric field is always perpendicular to the equipotential surface. So to prove it, we consider unit amount of charge. So what will be the force? For unit charge, the force will be electric field. So what will be the work done in taking the charge from A to B? Simply F dot dr, that is E dot dr. And we also know that the work done is 0. So E dot dr is 0. That means E is perpendicular to dr. Okay. So electric field is always perpendicular to the equipotential surface. Okay. So this is the second property. Okay. Now, third property is that no two equipotential surface can intersect each other. Okay, so no two equipotential surface can intersect each other. This is not possible, because if they intersect, we all know that at the point of intersection there will be two values of potential, which is not possible. Okay, so if they do so, comma, at point of intersection there are two values of potential. This is not possible. Okay, so this is what about equipotential surface. Okay, that is the work done in taking an object from one point to another point in an equipotential surface is 0. No two equipotential surface can intersect each other. So if they do so, there are two values of potential at the point of intersection. This is not possible. And we have also seen that electric field is always perpendicular to the equipotential surface. Now somebody asked me a question that I am going to discuss. That the question is a very important question and I forgot to tell it. This is a very important question, that's why I write it VVI. Okay, the question is why moon has no atmosphere. This is a very important question. Why moon has no atmosphere? Now previously I have told about the escape velocity. Okay, I told about the escape velocity, that is the minimum velocity with which a body is projected so that it can leave the gravitational pull of Earth, or you can say any other planet. Okay, now and there we see that the escape velocity depends upon the radius and acceleration due to gravity of the planet. That means you see g. Okay, so you all know that in case of a moon, the acceleration due to gravity is very small, because if a object has weight 36 kg in Earth, then it has weight of 6 kg in moon. So for moon g is small. Okay, for moon g is small. So if g is small, v is what? Small. That means the gases that are inside the moon, okay, the gases which are inside the moon or at the atmosphere of moon will have greater thermal velocity than this escape velocity. That means this condition, this is the thermal velocity of the gases. Okay, we all know that acceleration due to gravity is small, so g is small, so escape velocity at moon is very small. Okay, in compared to the thermal velocity of the gases. Okay, so v is greater than v. So what happens if the thermal velocity of the gases are large than this escape velocity? Then all the gases will escape from moon surface. No gas will remain at the surface of moon. That's why moon has no atmosphere. Okay, so thermal velocity of all gases are very high, so that they can easily lift moon's surface. So moon has no atmosphere. Okay, at moon g is small, so v is small. That means the thermal velocity of the gases that are in the atmosphere will have greater thermal velocity than this escape velocity. So if v is large, so they will easily escape from moon surface. So that's why moon has no atmosphere. Okay, so this is a very important question. Okay, so this is the answer. So we can easily explain it from escape velocity. So with this I finished the second chapter of classical mechanics, that is gravitation. Now from next day I will start the third chapter, that is conservation theorems in classical mechanics. Okay, that I will start in the next class. So if you don't subscribe my channel, then kindly subscribe it to get latest videos on physics. Thank you.